This is Geometry Semester 2. It's the 14th unit called Probability Review. It's the first lesson called And, Multiply, or Add, Rat Maze Practice. It's on creatormath.com under the Geometry tab. You might have to Google creatormath.weebly.com to find it. Here are the instructions. It says copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. I try to show you where those notes are when I do a video, because it can be challenging for students. So let's see, here's the name of the website, creatormath.weebly.com. You might have to Google that. If you get to the home page, it should look like this. All right, everything about your composition book is under this. Go down until you find the large print composition book. Please read all the directions, follow all the directions, watch all the videos, follow or stick to the due dates, and put things where they go. If you do that, you should have a 90 to 100 on your composition book. Now, when it comes to the notes for the pages in the comp book, we have to go to the tab of the class we're in, which is geometry for this video. This is where all the video lessons, the vocabulary, the practice sets, and the practice problems, okay, are on this tab under geometry. So if you're not getting 100% on your vocabulary practices, please make sure you understand there is a vocabulary geometry practice study PDF here you can download to your device. It is searchable. Please Google, how do I search a PDF on the device you're using? It's a little bit different for different devices. And you should be getting 100% on those vocabularies. Next, I'm going to go to the semester for this video. This one happens to be semester 2. This is the table of contents. You should have already copied pages 2, all of these table of contents onto pages 2 through 6 of your composition book. If you have not, please stop what you're doing now and do it. Follow the videos on how to number the pages of your comp book and follow the examples of great comp books. So now we're going to find the unit. Here we go. Last unit, there's only one, so here's the unit. There's only one lesson in this. That's because it's a review unit, you guys. It's probability review. So last semester we did probability and we had 4 or 5 lessons. I kind of forget right now how many were back there. It's not too many because this is a geometry class, but we do want to introduce you to prob and stats. This one is called And, Multiply, and Or, Add, and Rat Maze, right? It's all the lessons of the prior semester lumped into one to help you to review. There should be notes here, and that'll link up next time, but that's where you'll be able to find it. Here are the problems we're working on now, and we're going to dive right into those and see what we can do. So here's the first problem. When Ronald goes to Big Burgers, all right, he orders a sandwich and a side order. For the sandwich, 50% of the time he orders a jumbo burger. Okay, so jumbo burger is 50%. Okay, 30% of the time he orders a chicken sandwich, so 30% for chicken sandwich. 20% of the time he orders a regular burger, 20%. So out of the 3 sandwich choices, there's 50, 30, 100, right? So those 3 choices he picks, and here's the probability of each. For the side, 25% of the time he orders regular fries, so here's 25% for reg fries. Curly fries are 40%. That sounds good to me right now. And the rest of the time he orders a salad. So rest of the time, so 40 and 25 would be 65%. That would leave 35% for a salad. All right, get a little healthy mix in there. I like that, either fries or salad, like the 2 opposite ends of the earth there in terms of food types and healthiness. Ronald, and I like the fries by the way personally, but Ronald just bought lunch. Okay, what is the probability he ordered a jumbo burger and regular fries? Okay, so jumbo burger with. So notice this is an and. A jumbo burger and regular fries. All right, here it is here. Probability of a jumbo burger and regular fries. So jumbo burger is 50%. And regular fries is 25%. Why am I multiplying them? Because it's and. Then see this or, there's a plus in here. Chicken sandwich with a salad. So now chicken salad is 30%, and a salad is times 35%. And if you go back to the original, what we did in probability, this will ring a bell. The hint should be in here. I'd sure like the hint. The hint is and multiply. or add, right? So here we had two things. We multiplied them because they're and. Or, so we add it to the other two things we had and, right? So a jumbo burger and regular fries, a chicken sandwich and salad. So the ands are multiplied, and because they're or between them, it's added. All right, so now we're going to use, let's use our calculator for this. We don't want to multiply decimals now, do we? So let's clear this out. Can you see that? Yes, you can. So this is 0.5 times 0.25, 0.5 times 0.25. And then we're going to say plus 0.3 times 0.35, 0.3 times 0.35, all right, 0.23 equals, right? There it is. All right, but the big hint, and the thing that I'll make sure is on there by the time you get to this one, okay, is and is multiply or is add. Let's try it again. Let's see how many they give us of these. Okay, Les is known for making errors when correcting his students' papers. So Les must be a teacher. On any given problem, he has 40% chance of grading the problem correctly. That is, marking a correct solution as correct or wrong solution as incorrect. Okay, he has a 40% chance of grading correctly. All right, 40% correctly graded. Correct grading. Wow, that's pretty low, just off the top of my head. I wish it was higher. As a teacher, hope I'm higher than that. Okay, I'm higher in calculating that a correct problem than that. Let's put it that way, right? So Victoria is pretty good at math, but on any given problem, she has 80% chance of getting the correct answer. Victoria just took a one-question quiz in Mr. Less's class, right? What is the probability that she will get 100%? What is the probability that she does the problem correctly but is marked wrong? Explain your answer. So yeah, I like the notation they're using. What's the probability of 100%? That's one issue, right? And what's the probability she'll get it correct but marked wrong? So probability correct but marked wrong. Okay, so I think, let's think about this. What's the probability she gets it correct? She has an 80% chance of correct, right? 80% chance of correct, right? And 40% chance of grading correct, right? That means a 60% chance of grading wrong, right? Because that has to add to 100. So this one says she gets the problem correct. So that's an 80% chance right there that she gets it correct. But then there's a 60% chance that the person marks it, that Les marks it, the teacher marks it wrong. So this would be times, because you have to have and. And is multiply, right? Let's look back at our hint. And is multiply, or is add. So it's not one or the other. She has to get it correct, 80%. And he has to mark it wrong, 60%, right? So this probability is going to be 0.8 times 0.6. 0.8 times 0.6, right, is 0.48. So this one's going to be 0.48. And if I look at my answer choices here, this is 0.2, 0.32, these are all out. All right? So I'm pretty sure this is it. Let's go back and see the chance that she gets it correct is 80%, and the chance that he grades it correct is 40%. So that would be 0.8 times 0.4. 4 times 8 is 32, right? So that would be, and move the decimal 2 places, is 0.32. So this is the probability here of getting it 100% is 32% probability. And getting the probability of getting it correct but marked wrong is 48%, right? All right, at her archery lesson, Tess has a 90% chance of hitting a bullseye. So, bullseye. That's right in the middle, right? I think that's what a bullseye is, 90% chance. Unfortunately, there's only a 40% chance that her instructor will be watching when she shoots. Instructor watching. 40%. And you'll rewrite these, you guys. You'll see me rewrite them because there's a lot of information here. It's a lot for your brain to process. At least it is for mine. So what is the probability that her instructor will see Tess So 40% hit the bullseye, and she hits the bullseye. It's an and, so we multiply. So 0.9 times 0.4. 4 times 9 is 36, and move the decimal place two places. So 0.36, probability of a bullseye. 0.36. And notice I use my calculator at first, but then I'm like, let's start to cut corners, right? Otherwise this lesson gets too long. All right. The two spinners shown to the right are spun. If the letters match, you win. Otherwise, you lose. What is the probability you win? Use an area or tree diagram to help solve problems. Show all calculations to your result. So here's the probability here, right? And we want to match, what is it? If the letters match, you win. What is the probability you win? So the probability of matching letters. Right? So that would be the probability of an A and an A, right? And because it's and, they must be multiplied in there, right? So I can put A and A, but I'm going to multiply the probability of A and A. So the probability of A here is 1/4 times the probability of A here is 1/2, right? So this equals 1/8. All right, that's one option. Then I got a probability of a B and a B, right? B here is 3/8, and B here is 1/4. So that's 3 over 32. Can I reduce that? I don't think so. Nope, nope. And then the probability of a C and a C equals, C is 3/8 times 1/4. So it looks like 3 over 32. So now, the whole thing about this is that I can get any of these three to meet what they said. I can win with either of these three. So I can do this, or this, or this. What do we know about or? We add these. So now we take 1/8 plus 3 over 32 plus 3 over 32. So we're going to use 32 as our common denominator. So fortunately, these don't change. 4 times 8 is 32. 4 times 1 is 4. So 4 plus 6 is 10 over 32. But I can divide the 10 by 2 and get 5, and the 32 by 2 and get 16. 5/16. I reduce it. So the P of a match is 5/16. Pretty complicated, but maybe easy in concept, but complicated in calculation. Boris the rat is trying to find food in the maze shown below. Boris is equally likely to take any path when coming to an intersection. If the food is stored in A, so here, what is the probability that Boris finds food? Show all your calculations. So we just did one of these in the prior lesson, right? If this is 1/3, 1/3, 1/3, right? If this is 1/2, 1/2. If this is 1/2, 1/2. And this is 1/3, 1/3, 1/3. And the rat can go through here, this, or this, or this, or this, right? So these are and up here. And is multiply, or I'd like to hint on all these, right? I'd like to hint on this one too. So this is 1/6 to get to here. This is 1/3 to get to here. This is 1/6 to get to here. And this is 3 times 3 is 9, times 2 is 18. 1/18 to get to here. I could take 1, 2, 3, 4 paths, so let me write that a little bit more clearly. I'm sorry, guys, to get so cryptic in there. Plus 1/18. So, or, now we can add all these. So 18th goes 3. 18th goes 6. 18th goes 3. That's 12. Plus 1/18 is 13/18. That's my chance. The probability of getting to A is 13/18 chance, or probability. All right. The bar graph below at the right shows the probability of different colored sections coming up when a spinner is spun. Unfortunately, part of the graph has been ripped off. If only one color is missing, green, from this picture, what is the probability that green will come up? Explain completely to justify your answer. Oh, I don't know if I can see this well enough. Okay, so let's try to do this. Let me read the answers too. The probabilities must sum to 1. Okay, so P of green is 1/8. Right? So it looks like on the graph this is 1. Looks like something has gone here. I'm not totally sure of this graph, you guys. Oh, yellow is here. Wow, no, I can't see the yellow. See, this is made to be a color drawing that shows up on your screen, and I think you're going to be okay when you see it on the screen. But for us doing this right here, this is challenging. So yellow, if this is 1, I don't see the markings on the side here either. I might not be able to do this one, you guys, but let's see. Is that a marking here and here? 3, 4, 5, 6, 7, 8, maybe? Ah, 8s. I like that. All right, so here's 1, 2, 3 8s, 4 8s, 5 8s, 6 8s, 7 8s. And there's 1/8 missing. So I'm counting up the number of 8s. If this, and I apologize, this is terrible to have a graphic like this. You can see it when you see the computer, but in this paper form, it's not coming out right. So this is 1, 2, 3, 4 8s, 5, 6, 7, 8 8s. That's 1. This is 1/2, and it's broken into 8s. This is 1, 2, 3 8s, 3 8s. This is 1/8 here, because it's 1/8 high, right? And this is 1, 2, 3, 3 8s here. And 3, 4, 5, 6, 7 8s. I've got 7 8s. What's missing? Whatever this torn part is, has to be 1/8 missing. And you're going to have an easier time when you see the actual diagram on the computer, okay? So sorry about that. All right, given the bubbles, choose as many as possible that can be used to make a logical flowchart and make the flowchart. Gerald likes Snoop Dogg. Gerald brushes his teeth every day. Gerald is at the burger joint. Gerald uses the crosswalk to get a CD signed by Snoop Dogg. Given the bubbles, choose as many possible that can be used to make a logical flowchart and make the flowchart. Gerald walks to buy a CD signed by DJ Jazzy Jeff. Wow. A sign outside the CD shop across the street from the burger joint says Snoop Dogg is signing CD covers. So I think a bubble chart is, ordering what's happening here, right? The sign outside the CD shop has to be before Gerald walks there, right? So I know that this has got to go this way. Gerald uses a crosswalk to get a CD signed by Snoop. Okay, Gerald is at the burger joint. Gerald likes Snoop Dogg. Gerald brushes his teeth every day. Huh. I don't know what this has to do with anything. Okay. Gerald uses a crosswalk. Well, okay, so this one is a sign outside the CD shop across the street from the burger joint says Snoop Dogg is signing. This has got to be before Gerald uses the crosswalk to get a CD signed by Snoop Dogg. And I'm starting to look at the answers too. A sign outside the CD shop across the street uses the crosswalk. Hey, so I like this going to this one, right? What do they have before this? Like Snoop Dogg. Gerald likes Snoop Dogg. Would this be before the sign outside the CD shop across the street from the burger joint? So I kind of see where they're going with this, and I'm kind of just going, I'm back going from this answer right here, right? So this would have to be before this one, and this would have to be before this one. The brush teeth I don't like at all, and it's not in this answer. All right, do they all have brush teeth in it somewhere? Let's see. Brushes teeth, so I'm letting go of this one, you guys. A sign outside the CD shop. This is just one. I don't like that. Does it continue on another page or something? Nope. So I don't like that answer. So I'd go with this one right here. Okay? Sounds a little obtuse, though. Not sure I like that example, but I think it goes back to some of the other examples we had done prior. That's where it's coming from. Okay, the Greeks noticed a relationship between the sum of consecutive odd numbers and perfect squares. Extend and examine the table below, then explain the relationship. Is this all one problem? Can I see it all on there at the same time? So, and this is a famous order. 1 plus 3 is 4, so this is a perfect square, perfect square, perfect square. What's a perfect square? The square root of 1 is 1, an integer. The square root of 4 is 2. And you should know that by now in this class because we've covered this before, square root of 9. But quick review, all right? Square root of 16. These are all called perfect squares because they produce square roots, which are integers, all right? So if I see where we're headed here, can't we just say 1 plus 3 plus 5 plus 7 plus 9? Right? And wouldn't that give us 16 plus 9 is 25? And if they did 1 dot, 4 dots, which would be 3 plus the 1. Okay. 1 dot, 2 dot. Well, they're just mapping out, they're mapping out the perfect square here. This is 1, 4, 9, 16. This has got to be 25 dots, which has got to be 1, 2, 3, 4, and a fifth. 1, 2, 3, 4, and a fifth, and fill those in. What are my answer choices? Draw the next figure in the sequence and explain how this proves the relationship between the sum of consecutive odds and perfect squares. Well, it's the next one in order. We're going to get 25, so we need 25 dots. The alternating between open and closed circles, oh, I can't see that very well. I don't know if I need that or not. I'm drawing 25 dots. I don't even need to see that part. Okay, so please make sure you're matching up the title of the video with the problem set you're doing. This is Geometry Semester 2. It's the unit called Probability Review, number 14, and it's the first lesson called And Multiply or Add and Rat Maze Practice. All right, it's on creatormath.com under the Geometry tab. Hope that helps.